and I grew strong, and I learned how to get along, and so you're back.
All right. Good afternoon, everyone. I know you're very upset that I'm not here today. I'm so sorry, but unfortunately I am getting a couple teeth extracted. And, yeah. So, I just want to remind you that your book money is due. I know you probably have it today. If you have it today, and tomorrow, I'll still give you the 5 extra points. All right, make sure that you're going to copy down your homework from the sideboard and that you have taken the notes for today. All right, I will be after school tomorrow. All right, I had to change it to Tuesday. So if you need to stay to make up any work or you need to go over any material, any factoring that we've been working on, make sure you stay. So we're going to continue our journey with factoring. All right, so what I want you to work on first is to multiply the following conjugate pairs. So if you notice, this was one of our special products, the product of sum and difference. So when you have x plus 2 times x minus 2, if you remember what we end up getting, so you should be doing this with me as I do this on the board. What happens to the 2 middle terms? All right, remember this. What happens to the 2 middle? So if it's negative 2 plus 2, if you remember, the middle 2 terms drop out and you're just left with x squared minus 4. Okay, remember, you didn't have to remember the pattern. Okay, 4x times 4x is 16x squared. 4x times negative 5. 5 times 4x. There are our opposites. What happens with the middle 2 terms? They make 0. So we're left with 16x squared minus 25. Okay? So factoring is to write an expression as a product. So if you remember, it's going the reverse of really what we've been doing, which is distributed. So we're going to talk about how do you factor something that's x squared minus 4, something that looks like x squared minus 9, x squared minus 16. Okay, do you notice the pattern that I'm doing with those expressions? 4, 9, 16. Okay, they're perfect squares. So the factoring method we're learning today is called DOTS, D-O-T-S. And it's an acronym for difference of 2 perfect squares. Okay, so we're using this factoring method when we have a difference, which means subtraction, and when you have 2 perfect squares. So you have x squared is a perfect square, and 4 is a perfect square. So how you would factor them is, we're going to start by putting 2 sets of parentheses. What's the square root of x squared? X times x, plus and minus. That's always standard. Plus and minus is standard. And then we take the square root of 4, which is 2. Okay, let me give you another one. If I do x squared minus, let's say, 121. The key here is that we have the difference. Difference is subtraction of 2 perfect squares. So I put 2 sets of parentheses, and technically what I do is I take the square root of x squared. I put that in the beginning. Then I take the square root of 121, which is 11, put a plus, I put a minus. Okay? This happens to be one of my favorite factoring methods. Alright, so in a moment you're going to work on the other examples that are listed for you. I want to skip over to example 2, and then you can work backwards. All right. So if you have something now that I'm putting a number in front of your x squared, okay? If you notice, that number, 25, is a perfect square. Okay, so I still have the difference, because it's subtraction, of 2 perfect squares, because 25x squared and 1 are both perfect squares. All right, most kids forget that 1 is a perfect square. So I put my 2 sets of parentheses. You can go ahead and put plus and minus. Okay, then I'm going to take the square root of 25x squared. So what's the square root of 25? 5, and then it's x. So I'm going to put 5x in the beginning, and then I'm going to take the square root of 1 is 1 at the end. And that would be my final answer. Okay, a couple other ones I want to discuss that you'll see as you get to the challenge. What happens if it's not x squared and it's x to the 4th? Okay. So we have the difference, and 100 is definitely a perfect square, x to the 4th. Okay. The square root of x to the 4th is just x squared. So any even exponent is a perfect square. Okay, so this is dots. The square root of x to the 4th is x squared. That goes in the beginning. Plus and minus. The square root of 100 is 10. And we're done. If it's x cubed, or x to the 5th, you cannot do that. Those are not perfect squares. All right, some other things. These are ones that cannot be factored. And let's talk about why these can't be factored. So I'm going to start with x squared plus 9. Okay, it cannot be factored because it is not subtraction. Let's talk about x squared minus 5. Okay, these are not perfect squares. All right, so what you're going to continue to do is you're going to go back to exercise 1. Then you're going to move on to exercise 2. Then you're going to do the soccer fields. Okay, if you remember, a soccer field is a rectangle. Okay, so if you have area, it's asking for the sides. Then we're asking for the perimeter. Okay. And then you're going to work on the challenge questions at the very end. All right, and your homework is listed on the side board. If you get time at the end, it'll be on the board. If not, you'll have to do it tonight, and I will pick up where we left off. All right, and don't forget that you need to bring in your $2.50 for your book. All right, see you tomorrow.